If what you're about to see had been shown in physics classes, the world might have turned out very differently. Because then we would have known since childhood how fascinating the world is and what amazing phenomena can be observed and studied in it. So, let's be amazed. Lighting a candle through smoke. In these shots, it seems like the candle was lit through the smoke. How is that possible? In reality, it's the paraffin vapors that are ignited, which evaporate from the wick, so the candle lights up again. There are other interesting shots with the candle as well. For example, here's how a wick burns when twisted into a spiral.
And the flame of a candle can also conduct electric current.
And you can also create this kind of silver coating illusion using a candle and an egg.
Although eggs are capable of even more, they can withstand a shredder which can swallow anything, including entire machines.
And here is the most visual demonstration of the Pythagorean theorem in the world. The sum of the squares of the legs is equal to the square of the hypotenuse. Show this Pythagorean demo to your geometry teacher. Let him appreciate it. And this is a demonstration of just 2 words. The speed of color. Researchers from the Swiss Federal Institute of Technology in Lausanne used a special camera in their experiment with a shutter that opens once every 3.8 nanoseconds, which allowed filming at a speed of 24,000 frames per second. Lasers were used and camera pulses opened the shutter to track the propagation of light.
Ultrafast filming makes it possible to see the movement of a light beam without moving the camera and without overlaying images from other cameras.
And here are some more interesting shots where not only light but also electricity is involved. In northern India, 4 people hid under a tree from the rain and were all struck by lightning together. They survived but ended up in the hospital.
A clear example for those who think it's a great idea to wait out a thunderstorm under a tree.
And this is a great example of how knowledge of physics can be useful in real life. When engineers like this don't have a pole with a wheel at hand, they get bored and start making homemade toys. All they need for this is some wire, a battery, and a bit of imagination. Although there are quite a few designs like this, here's another option. Or you can make an electric motor for a bicycle yourself. And you can also run 1,000,000 volts through the legendary Nokia 3310. And in this experiment, it not only survived but was also able to find a network and receive a call. Truly an indestructible device. Probably enthusiasts like that. If the neighbor's kids are making too much noise, tell them through the wall, "I'm a little gnome living in the socket, and I need to be fed 2 fresh nails."
Or they work as electricians and install these tough Chelyabinsk LEDs that indicate a slight overload. By the way, this Nokia is so tough that people even used it instead of a brake pad.
It's amazing, of course, that the asphalt wasn't damaged. Alright, now seriously, let's take a look at real levitation. Rub the straw and voila! Or here are some kitchen miracles available to everyone. They're related to a phenomenon called surface tension. And this Chinese guy is clearly doing something with the laws of physics. Although, to be fair, there are quite a few skilled people who can work with balance like this. And now it's time to fly. Back at the turn of the millennium, the first flights in wingsuits caught the public's attention and sparked a new wave of videos shot with GoPro cameras. Extreme sports enthusiasts quickly mastered this new way of moving and began to amaze audiences with their stunts, soaring between cliffs like giant flying squirrels. However, the devices were limited by gravity and had no other source of acceleration. For several years, stuntman Peter Salzman thought about how to expand the capabilities of the wingsuit.
As a result of his collaboration with engineers from the BMW studio, a prototype was created with 2 chest-mounted electric ducted fans.
They turned out to be relatively compact, but capable of delivering 25,000 revolutions per minute in mute. The propellers provide a total power of only 20 horsepower for 5 minutes. But that's enough. A regular wingsuit loses about 1 meter of altitude for every 3 meters of horizontal distance, and the speed does not exceed 100 kilometers per hour. But Salzman's project allows you to accelerate up to 300 kilometers per hour and gain altitude, not just gradually descend. However, not everyone is so lucky when it comes to flying. Or on the contrary, some are much luckier. It depends on how you look at it. At a hot air balloon festival in Hsinchu, Taiwan, a 3-year-old girl was carried away into the sky. The girl, who weighs about 13 kilograms, got tangled in the back of the kite. She tried to free herself, but the wind picked up and the kite suddenly took off. The girl was in the air for half a minute, after which the wind died down and she began to fall. The crowd of spectators caught the child. Local media report that the little girl was not injured. These shots are so shocking that you start to wonder if it's fake. Write in the comments what you think about this. Now let's move on to so-called spontaneous synchronization. And the secret behind the almost intelligent behavior of 5 metronomes lies not in the metronomes themselves, but in the platform on which they are placed. It can move slightly. The 2 cans at the bottom receive vibrations from the upper system and start vibrating themselves, sending the impulse back. The greatest impulse occurs when most of the pendulums tilt in the same direction. After that, positive feedback appears in the system, and the number of metronomes doesn't matter. Here, for example, there are 32 of them. In general, it's a clear illustration of what happens if you start rocking the boat. But let's move on to some hotter footage. Do you know how to touch 1500 degrees Celsius and not get burned? In this footage, you see the testing of thermal protection tiles for reusable space shuttles. When returning from space, the spacecraft rushes toward Earth at a speed of 27,360 km per hour, which causes the tiles to heat up to the melting point of steel. To prevent the spacecraft from burning up, this kind of thermal protection is installed. It gets extremely hot, but it doesn't transfer the heat. And finally, let's figure out this kind of levitation as well. What keeps a piece of metal from falling and makes it freeze in midair? The copper tube of the inductor is not a heating element, as you might think at first. It only serves as the core of the coil and directs the induced currents. The induced currents passing through the piece of metal not only keep it suspended, but also heat it up to a temperature of 1300 degrees Celsius.
This temperature is high enough to melt iron, aluminum, or copper.
Thus, this inductor allows you to melt metals right in the air, without any holders or refractory alloys. Such melting, without contact with the crucible, and without contaminating the sample with the crucible material, makes it possible to obtain ultra-pure alloy samples. But this kind of levitation metallurgy is a special case of induction melting furnaces, which are now widely used. For example, they are used to harden all kinds of parts, such as gears.
Moreover, in an induction furnace, not only surface hardening, but also deep, so-called through hardening can be performed. For example, this is how a crankshaft is hardened, and this is induction heating and bending of tungsten rods.
Let's wrap up here. We hope your understanding of physics is now deeper and more solid. Please give this episode a fair rating. See you in the next video on our channel.